next topic that we're going to take a look at is the mole. And we're talking about the mole, no, not the cuddly, cute, in illustrations, creature that digs tunnels in the earth and is blind, so on and so forth. No, we're talking about the chemistry mole. Well, what is that? Before we answer that question, let's take a look. My favorite chemical reaction. It's a single replacement reaction where we have solid copper reacting with a solution of silver nitrate to make silver, and then a solution of copper 2 nitrate. As you can see, we have to balance this reaction with coefficients. 2 silver nitrates and 2 silvers. And then obviously there are ones that we usually don't write because we are lazy in front of the copper and the copper 2 nitrate. So what do these 2's and these 1's mean? What do they mean when we balance a chemical reaction? When we put those digits in front of a chemical compound or an element, what are we talking about here? Are we talking about 1 atom of copper and 2 molecules of silver nitrate making 2 atoms of silver and 1 molecule of copper 2 nitrate? Well, not exactly, okay? We've seen this reaction happen. If what happened in that reaction was strictly on like a 1 atom of copper and 2 molecules of silver nitrate level, it'd be really hard for us to see. Definitely in a high school, don't have the equipment to be able to see things quite that small. So what do these numbers mean? Well, they represent number of moles. So you could say for this reaction, 1 mole of copper reacts with 2 moles of silver nitrate to form 2 moles of silver and 1 mole of copper 2 nitrate. Now maybe that doesn't make things any more clear because we still don't really know what the heck is a mole. So let's take a look. The mole, guys, is a term used to represent a certain quantity of particles, just like I've got some listed here, okay? If I said to you a dozen, oh, I need to run to the grocery store to get a dozen eggs, you would say, oh, that's right, you're going to get 12 eggs. Okay? If I said, oh, I've got a dozen donuts in this box for class today, well, you'd be really excited. I don't have those. Sorry. But you would know that that meant I had 12 donuts. Just like if I said, oh, a pair of socks. Well, in a pair of socks, there are 2. Pair doesn't apply to just socks, right? You could have a pair of students come to visit. You could have a pair of pencils. Generally, when we say pair, people understand that to mean 2. So pair is just a word that we use to represent a set quantity of 2. Ream is maybe one that you're not familiar with, and ream is generally used to talk about paper. So you know when you go to put more paper in your printer or in a photocopier or anything like that, and you undo a big package of paper, well, that package is called a ream, and it holds 500 sheets of paper. I don't know if we necessarily use the word ream to talk about any other objects other than paper, but you could if you wanted to. So just like dozen, pair, ream are all terms used to represent set quantities, so too is a mole. A mole's slightly bigger than these ones. Can you guess what it is? It's definitely higher than that. Whatever it was that you guessed, it's definitely higher. A mole is 6.02 times 10 to the 23rd particles. That's a lot of zeros. Okay, 6.02 times 10 to the 23rd. Now, let's think about it. A mole doesn't have to apply to just chemicals. It doesn't have to apply to just elements or atoms, and it doesn't have to apply to just molecules. Okay, a mole could apply to anything. Generally speaking, though, there's not really a whole lot of things that we have a mole of in this world. Like if you take a look and you expand this number, it's 602, and then draw 21 more zeros. There we go. That's how many zeros follow in a mole. There are less than 1 mole of people on this earth, right? There's only 7 billion people. That's far, far less than a mole. Well, who came up with this? There was a scientist. His name was Avogadro. And I guess he, in addition to liking chemistry, he also really liked to count. And he could count very, very high, very, very quickly. Just kidding. You could actually never count to a mole in your lifetime. That would take forever. If you want to read more about how did Avogadro discover or how did he come up with this seemingly random number, you can read up on that on your own. I'm sure there's great stories behind it. But he decided, oh, well, when we talk about a mole of particles, which you can actually see a mole of things, and we'll see that in a lab, okay, he said, oh, that's going to represent 6.02 times 10 to the 23rd. Now, lucky for us, we're not going to do any math with this number. Okay, I'm not going to ask you to calculate, oh, how many atoms would be present or so on and so forth. This is just something for you to kind of help you get your head wrapped around what does a mole mean. So a mole is a set quantity representing 6.02 times 10 to the 23rd particles. And if you get really excited about moles, you can celebrate Mole Day. And Mole Day is generally on October 23rd. See if you can figure out why that is. Now, the other thing that you can take a look at, if perhaps you learn about the mole too late in the year and it's past October 23rd, well, you can join the round 2 of Mole Day celebrations, which tend to take place on June the 2nd. So see if you can figure out why those dates are. Now, basically, knowing about moles doesn't necessarily help us in a lab. For example, I cannot say to you, hey, in this lab, I need you to measure out 3 moles of, for example, my favorite reaction, 3 moles of copper to react here. That's not helpful to you. Okay, there's not a scale that measures moles. There's not a piece of equipment that can measure moles. So what we need to do is we need to make calculations about moles indirectly by measuring mass directly, and then using something called a molar mass to help us determine the number of moles of a substance. So there's going to be a little bit of math coming up. Make sure you've got a calculator so you can work through these problems with me. Now, before we talk about big calculations, let's talk about molar mass. Now's a great time to grab your periodic table if you don't already have it out. So molar mass is the mass of 1 mole of a given substance, and it's different for every substance. Now, if you were an English teacher, you would be upset with me for defining a term, molar mass, using words in that term. That's how I'm going to do it. Molar mass is kind of given in the periodic table. I say kind of because if you really want to split hairs and be technical about the value shown in the periodic table, then you would need to know that that is actually in atomic mass units, not molar mass. For our purposes, we're going to say that it is molar mass. So I've got 4 examples listed here: helium, iron, carbon, and sodium. Take 2 seconds, find those on your periodic table. So if you take a look at the legend on your periodic table, it will show you where you can find the molar mass of substances. So for our periodic table, it's in the top right-hand corner, okay, directly across from the atomic number. Now, lots of people want to think that molar mass is the same as mass number, and it is not, okay. Mass number is number of protons plus number of neutrons, versus molar mass or atomic mass units is taking a look at all the weighted average of all the masses of all the isotopes of that particular substance. Okay, so please don't confuse molar mass with mass number. Very different things. Molar mass is in the periodic table, mass number is not. So If you found helium, helium is atomic number 2, and you can see that written there for helium in the top right is this value, 4.00. That's the molar mass of helium, except for molar masses need units, and those units are in grams. That's a unit of mass per mole. Okay, and look at how we abbreviate mole here. Isn't this crafty? Totally saving us time. We're abbreviating mole using MOL instead of MOLE. Very, very efficient. Okay, that is the abbreviation for mole. I didn't just make that up. Iron. Let's move on to our next one. Iron, if you found it, it's number 26. It has a molar mass, 55.85 grams per mole. Fun. Okay, carbon. Carbon, the symbol for carbon is C, right? You found it. It is atomic number 6 on the periodic table. Molar mass, 12.01 grams per mole. And finally, sodium, with the chemical symbol of Na. It is number 11 on your periodic table and has a molar mass of 22.99, oops, that's a decimal there, grams per mole. One thing you guys should know is that all molar masses have 2 digits after the decimal, even if you take a look at something like oxygen. Okay, oxygen, molar mass is not 16, it's 16.00. Okay, so always remember, keep 2 digits after the decimal for your molar mass. Now that was molar masses for atoms that we can look up on the periodic table. It gets a little bit different if we're taking a look at the molar mass of compounds. So to determine the molar mass of compounds, we must take into account the quantity of all atoms present. And so that's both the subscripts and the symbols. So here's some examples. Water is our first one. Symbol for water, or sorry, the formula for water rather, is H2O. So you guys can see that in water we've got 2 hydrogens and we've got 1 oxygen. That's an O for oxygen, not a 0. Okay? So 2 hydrogens means we have 2 times, what is the molar mass of 1 hydrogen? Well, it's 1.01. 2 times 1.01. And then when we have 1 oxygen, we've got 1 times the molar mass of oxygen, 16.00. Then what we'll do to figure out the molar mass of the compound is just add these 2 together. That will give us 18.02 grams per mole. And that is the molar mass of water. 1 mole of water has a mass of 18.02 grams. So you could measure out 1 mole of water. You would do that indirectly by putting a beaker or something, some sort of container, onto a scale and measuring out 18.02 grams of water. Once you've measured out 18.02 grams of water, you would say, this is 1 mole. This is how much? 6.02 times 10 to the 23rd molecules of water is. Okay? Magnesium phosphide is our next example. Let's take a look at the formula. Magnesium phosphide is Mg3P2. Okay, which means we've got 3 magnesiums and we've got 2 phosphoruses. Okay, so magnesium has a molar mass of 24.31. So we'll get 3 times 24.31. And phosphorus has a molar mass of 30.97. Okay, and then just simply add those 2 together. Now I'm thinking it'd be a great idea if I had actually calculated this or had a calculator with me. Let me figure that out. You pause this video so it's not taking up space for you, and you can do this math, and then go on and do calcium nitrate and oxygen and see if you can figure those 2 out. Okay, I'm back. I'm just calculating my molar mass there. And for magnesium phosphide, what I'm getting is 134.87 grams per mole. Fabulous. Now, if you took a look at calcium nitrate, first of all, and this is why we spent so much time figuring out how to write formulas, you need to know the correct formula for calcium nitrate. I'm going to switch colors so it doesn't get all muddled in here, but calcium nitrate, because calcium has that 2+ charge, we're going to have nitrate in brackets or parentheses with a 2 outside, okay? So we've got 1 calcium, we've got 2 nitrates, but nitrate we have to then break down into nitrogen and oxygen. So to figure out molar mass, we've got 1 calcium, we've got 2 nitrogens, and we've got 6 oxygens. Make sure you figure that out properly. Remember, this 2 outside the brackets applies to both the oxygens and the nitrogens. Okay? So calcium has a molar mass of 40.08 for 1 calcium, nitrogen 14.01, and oxygen, of which we have 6, 16.00. So adding all those together, you should come up with 164.10 grams per mole. Now, I hope that you moved on and did oxygen. If you didn't, make sure do it now before you watch. And if you have, let's take a look at what happens with oxygen. First of all, this was a trick. I put this in here on purpose. Oxygen, what you need to know is the formula for oxygen is O2. Remember, oxygen is a diatomic, and it needs to hang out with a buddy. Okay, that's why it's O2, which means the molar mass is going to be 2 times the molar mass for 1 oxygen, so 2 times 16, which is going to give us 32.00 grams per mole. So that's how we calculate molar mass. Making sure, first of all, it has to start at the beginning. It has to start with you have the correct chemical formula for the substance you're taking a look at. And then it also needs to go on into you are looking up the correct number off the periodic table and taking into account all the subscripts and everything there. Okay? So now we get to the math part. A little bit of algebra. Don't worry, it's not super intimidating. So what we can do is we can figure out, okay, if I know the molar mass of something, which I can always determine, right? That's never really going to be given to us, but I can always determine it as long as I know the correct formula of the substance. So I can use that molar mass to convert from a mass to a number of moles, or vice versa, from a number of moles to a mass, okay, using the formula N equals little m over big M. Make sure your 2 M's look completely different from one another. N equals little m over big M. What do these mean? Well, N stands for number of moles. And the unit that we measure that in is the mole, MOL. Little m, guys, stands for mass of a substance, and that's going to be measured in grams. And then big M, you may have guessed, is going to be the molar mass. And that, we've already looked at, is measured in grams per mole. Some of you guys might be interested in a formula triangle. If you're not sure what a formula triangle is, I'm going to draw it and we can have that conversation about how do I use this, okay? Because you're not always going to be solving for N. Sometimes you'll be solving for little m as well. So if you want to set up your formula triangle, it looks like this, with little m in the top section and big M in the bottom section. And if you have questions on how to use a formula triangle, come see me and I can help you out with that. Basically, it's used so that you can convert from this given version of the formula, n equals little m over big M, and you can convert that to solve for little m quite easily. Okay. Let's take a look at some examples. These are in your notes. So our first example asks us to determine the number of moles of potassium permanganate. Well, first of all, we need to know the correct formula for potassium permanganate. That's generally quite helpful. Formula for potassium permanganate, KMnO4. No parentheses, that's it there. Okay? Now, I have a specific way I'd like for you to solve problems in chemistry. You will need to go through that way in order to earn full marks. I will show you where your points are going to be earned as we go through and do this question. So the first thing I need to do is list my variables. Variables that I need to list can include this chemical formula. Okay? I also need to list anything else that I'm told or can determine. So I'm given, as you can see on your paper, also up here, okay, I'm given a mass of 34.7 grams. Okay? And I can calculate the molar mass of potassium permanganate. If you'd like, you can pause the video, test yourself, see if you can come up with this. (158.04 grams per mole. And we are asked to come up with the number of moles. Okay? So we've listed things that we know. We've listed what it is we're being asked to find out or are unknown. Now we need to write down the formula in its correct form. So this one, we're solving for N, and we know that formula is mass, or little m, over molar mass, big M. Okay, so we can substitute in our values now. Our mass, 34.7 grams, and our molar mass of 158.04 grams per mole. And now it just becomes relatively straightforward division here. So 34.7 divide by 158.04, and you'll get an answer of 0.2195 ... Okay, and then let's round this right now. Let's round this to 2 digits after the decimal. So 0.22. Okay. We also need to have units in our answer. That's very crucial. 0.22 moles. Okay. So if I was grading this, if it was on a quiz or a test or an exam, anything like that, here's what it would look like. You would get 1 mark for listing all your variables. You would get 1 mark for having the proper formula in its proper form, and you get 1 mark for the answer. You guys need to get in the habit of showing all your work if you want to earn all your marks. Okay, so please do that in your homework so that when it comes time for marks, you will be able to earn all of them. Let's do one last example here. We've got ammonium sulfate, okay, and we've given you the formula. So it's NH4 in parentheses 2SO4. All right, perfect. Well, that's one last thing that I will have to list. So now I just need to go ahead and go with what information I'm given. So I'm told that the number of moles is 0.19. And I can calculate the molar mass. Again, pause the video, calculate this on your own. Make sure you can come up with the same number. And I'm being asked to find, well, how much mass would that have? Okay, if I had 0.19 moles, what would the mass of that be? Okay, so I've listed all my known variables. I've identified my unknown variable, what it is I'm looking for. Now I need to write the formula in its correct version. You'll notice here that we're solving for little m, not n. So I need to rearrange my formula. Okay, rearrange my formula before I substitute in values. Okay, so all I'm going to do is 0.19 moles times 132.16 grams per mole. And I come up with, again, we're going to go with 2 digits after the decimal, so 25.11 grams. Okay, remembering to include units with your answer. Where do you get marks? Again, 1 mark for listing your variables, 1 mark for the correct formula in its correct version, and 1 mark for your answer with correct units. As with everything else that we've done in chemistry, it's important that you get some practice in. This is a concept that, again, you will require both your calculator and your periodic table for. And please come let me know if you have some questions and we'll work through things together. Thanks, guys.